18.6. This time we're going to talk about preparation of soluble salt, which contained sodium ion, potassium ion, and also ammonium ion. In the previous videos, we talked about preparation of soluble salts. Okay, so for soluble salts with sodium ion, potassium ion, and ammonium ion, we know that we are going to use a method called titration. So this video we're going to talk about what is titration and how we're going to prepare the salts and then how we're going to separate and purify them. So for preparations of these salts, we have two kinds of reactions. First of all, we can have alkali mixed with acid. If you still remember, alkali means soluble base. That means that in process alkaline plus acid, we are having two liquid or two solutions mixing together. Say for example, if we want to prepare sodium chloride, so we can mixing sodium hydroxide, which is an aqueous solutions, with an acid, hydrochloric acid. When these two things mix together, they will form sodium chloride. Other than this reaction, we can also mix carbonate solution. I have to emphasize this is carbonate solution. If it's just a normal carbonate, some of the carbonate, they will be insoluble. They have to be in solid state. Then at that time, that will not be counted as these situations. That won't be counted as a titration method. Because titration method, as what you have seen below, we're involving solution 1 and solution 2. Both of them have to be able to prepare in aqueous form. Otherwise, titration cannot be carried out. So in this case, if we also want to prepare sodium chloride, actually we can use sodium carbonate mixed with acid to give sodium chloride, carbon dioxide, and water. But I strongly recommend you to use the above equation. Say for example, if you talk about K, then maybe we're looking for potassium hydroxide mixed with hydrochloric acid. If you talk about ammonium, you're using NH3. If you talk about Na, then you're using NaOH. That would be more preferable, because for the carbonate, maybe you mix up some carbonate, say magnesium carbonate. That will be insoluble. Then that will be the case. Difficult to will be easy to get wrong. And write a wrong equations for that. So highly recommend you to when you talk about titrations, mixing alkaline and acid together. So the setup, it will be look like this. We have an apparatus. The apparatus called Burette. So more details, we'll talk about in the next chapter. But Burette, is a apparatus which help us measure exactly how much volumes, accurately the volume of solution that transfer, in this case, into the conical flask. So this is a very accurate apparatus, so it can help us to measure the volume of acid used. So we got acid above. Sometimes you may put alkaline, but most of the time we put acid above in the burette, and then in the conical flask we're going to put the alkaline. I'll put the alkaline. So we have alkaline in it. But if you know that, NaOH and HCl, actually both of them, they are colorless. If they are both colorless, so imagine, we have NaOH down here. Let's say we have 3 NaOH. And then, we have the acid, adding from above, that is HCl. So if I add the first HCl here, they will neutralize the NaOH. The second HCl, it will also neutralize the NaOH. But both of them, they are colorless. Actually, I don't know whether they will neutralize it or not. If I add the third one, they add into it. I just don't have enough space. Add into it, they can neutralize the last NaOH. At this point, after you add 3 HCl in it, actually the neutralization have occurred. However, you don't know that will be the end point. So what happened to you? You may continue to add the HCl, and then you're adding more and more. The solution, will become acidic instead of alkaline. So how can I know that, the end point will reach? It will depend on the indicator. So recall in chapter 16, we did learn something called indicator. It shows us that, the acidity and alkalinity of the solution. So in this case, if I use, say for example, if I use methyl orange, at the beginning, it is an alkaline solution. Then at the beginning, it will be yellow in color. And then when we add HCl in it, okay, less and less NaOH, and finally become neutral, maybe, okay, they will then turn into orange. If you extra add the HCl, then they may go to red. So the color will tell you that, okay, the acidity and alkalinity of this solution. Okay, so for this one, okay, remember the exam require you. This one is one of the most popular setup where that requires you to draw. So the sketch, okay, you have to draw this setup. Okay, so I recommend you every setup you need to label it. Okay, so you have 3A and 3C. Okay, what is 3A, 3AC? That means 3 apparatus you must label. You have Burette, conical flask, and white tile. Okay, so take a closer look. You'll see that actually we got a white tile here. Okay, so the white tile allow us to observe the color change easier. Well, and then 3 chemicals. Okay, you see that I put bracket here because every time, okay, the acid use will be different, alkaline use will be different, indicator use will be different. So therefore, the 3 chemicals, okay, it really changes, okay, from time to time. So say for example for this one, okay, we will have HCl here, NaOH here, maybe methyl orange in this case. Okay, so this setup, okay, you need to learn how to sketch it. Okay, so very quickly, maybe I will sketch you once. Okay, you need to do is just a long parallel line. Okay, like this. You have a stand and clamp. Remember, leave some space for the white tile. So this is the solution. The stand and clamp you can just draw like this, will be all right. So the setup, okay, it just look like this, and then just label. Okay, what are the Burette, conical flask, white tile, and then the solution inside? Okay, that will be already 2 marks for that. Okay, so titration, we'll have a SB8 on titration, but I will show you the videos later on. But right now, we'll just have a quick look how the titrations will do. Okay, so this experiment, scan it, okay, and have a look. What is that? So the experimental procedures, okay, basically, okay, we have to add. Very first step, we have to place known volume of alkaline into the conical flask. Okay, say for example, I'm going to put 25 cm cube of alkaline in the conical flask, and then I will add a few drops of indicator. In this case, we have used methyl orange. Then you will say, add a few drops of methyl orange in conical flask. This is a preparation of the conical flask solutions. Then, okay, you add the dilute hydrochloric acid into the burette, and what you need to do is just add, or sometimes we'll use the word run. Okay, run the acid from the burette, okay, into the conical flask. In the process, you keep swirling the solutions, so allow the reaction between hydrochloric acid and sodium hydroxide mix well, okay, in it. So when will we stop? Okay, we will add the solutions, okay, until, okay, the solutions turn into persistent orange color. Okay, turn into persistent orange color. So the solutions, if it reach orange color, you should stop not adding the HCl. If you continue to add HCl, then the color, okay, will then change to red. Okay, and then afterwards, okay, you will have the salt solution, because that is the end point already. So if it turns red, that means that, okay, you have the sodium chloride solution already. Okay, you have sodium chloride solution, but this one is sodium chloride and also water. Okay, but not only this, okay, because it is orange in color, you know that sodium chloride should be colorless. Okay, so the orange is coming from methyl orange. You don't want to have the methyl orange after you evaporate all the water away. If you don't get rid of the methyl orange, actually the salt that you prepare will have sodium chloride together with some of the methyl orange. So the next step is one of the most important step, okay, in this setup. In this in these steps, okay, what we're going to do, we're going to eliminate the methyl orange. How are we going to do it? Okay, basically, okay, you can repeat. Okay, the most common way is repeat the experiment with exact the same volume of acid and alkaline use, but this time we don't add indicator. What means by that? Just now we said that, okay, if the solution here is 25 cm cube, and the one that I add in it is 12.5 cm cube. So what we're going to do, okay, we just use another 25 cm cube together with 12.5 cm cube. We just mix these two colorless together. colorless liquid together. So we assume they have already finished the neutralization. Okay, without the help of indicator, actually we can't tell, but based on previous experiments, we can know, okay, the neutralization occurred when 12.5 cm³ added into it. Do remember, okay, this is the most important step. Repeat the experiment with this exactly same volume of acid alkaline used, but without the indicator. Okay, after that, okay, this time you will have a colorless solution which contain the sodium chloride and also water. So what you need to do next, okay, just boil off the water, okay, or just concentrate the solutions, okay, and then we can use crystallization, filter, wash, and dry, okay. So basically, the next step, okay, will be very similar to the previous videos. Boil to concentrate the solution, cool to crystallize, okay, and then forming some salt here. Then you have to do next is filter, wash, and dry. Remember, this time the salt that we're going to prepare is also soluble salt. So when you wash, do remember you have small amount of cold water to wash it. Okay, so basically, okay, doing this, okay, we can obtain a soluble salt, okay, which is sodium chloride. Okay, so how to remove the color of the acid alkaline indicator? Just as we mentioned the first one, okay, that will be the most common one. We will repeat the experiment with exact volume of acid and alkaline used, but do not add acid alkaline indicator this time. Okay, so you may ask, okay, how to remove the color, okay, of the solutions? Then this will be a most popular answer for that. But other than that, actually, okay, we can also warm the solution with activated carbon, because activated carbon, okay, or activated charcoal, it is used some of the time, okay, will be used to absorb colorings, okay, or absorb smell or things like that. Okay, so you can warm the solutions. Say for example, you have the salt solution with methyl orange, NaCl, and also water. What you need to do, okay, you just add some activated carbon in it. Okay, normally it's black in color, and leave it there. Then the activated carbon, they will have holes in it, where they may then trap the methyl orange, and then the methyl orange will be gone, and you will have the sodium chloride left behind. Okay, so we seldom use this one because it takes time, and also it's not really like completely colorless. Okay, so the better way, okay, I recommend you the first statement. Okay, so this QR code, okay, you can also scan in it, okay, to see the function of activated carbon to absorb odor and also color. So the procedures, okay, just how we have mentioned, okay, remember you have to place known volume. Say for example, you just make it up normally 25 cm³ in the conical flask, and then you also need to add a few drops of methyl orange. Okay, so every titration will be different, the indicator that we're going to use. Okay, next chapters we will learn a little bit more about that. Okay, but in this case, okay, we will know that we'll add methyl orange to give the yellow color. These are important information. Second one, fill the burette with HCl, okay, and then you run the HCl into the conical flask, okay, until the solutions turn persistent orange. Okay, and then you have to record the volume of acid used. With this one, just how we mentioned, you have to repeat the experiment with exact volume of acid alkaline used, but most important is no indicator this time. Okay, and then afterwards, okay, you boil to concentrate, cool to crystallize, okay, filter by filtration, wash with small amount of water, and then dry the crystal with filter paper if you're using hydrated salt, or often when you talk about anhydrous salt. This is a typical procedures, okay, to prepare soluble salt. Okay, please prepare, okay, in public exam. Normally this will be essay type questions. Okay, essay type question. Remember, no point form. Okay, and then complete sentence, and then better to write in paragraph. Okay, so the essays, okay, normally they will include 1 point of communication marks. Okay, so do remember, okay, when you revise this chapter, okay, you have to know how to write a procedures for preparing sodium chloride salts. So examples, okay, preparing salt by acid alkaline. So which of the following following ways of preparing a salt cannot be done by titration, cannot be done. Remember, the titration is only for the salts which have Na plus, K plus, and also NH4 plus. And for the titration, it have to include two solutions, okay, solution 1 and solution 2. So if you come across some of them, they are not solution, they cannot form solution. Most likely, they cannot be done by acid-alkaline titration. So first of all, we check the first one first, okay. Sodium, potassium, and ammonia. Which of the following salts they are not, okay. So this one is not, this one is not, okay, this one is not. So B, C, E, they are wrong. Okay, so A and D, okay, this one is solution, 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 and solution. Okay, D, okay, just want to familiarize with you. So ammonia solution is NH3, and then you have sulfuric acid. So when you add them together, you have ammonium sulfate. So this is the equation for that. Okay, so why B cannot? Okay, because this one is a solid. Is that right? This one is solid. Magnesium oxide, okay, they are not solution. Zinc hydroxide, you learned it before, it is a white precipitate. Is that right? That means it is also solid. Last one, copper 2 carbonate. If you still remember, most of the carbonate, they are insoluble. Okay, this one is also insoluble. So therefore, 3 of them, they are solid. They cannot be put into the burette, okay, for the titration. So therefore, this is wrong, okay. So for 3 of them, you see that magnesium oxide, zinc hydroxide, copper 2 sulfate are insoluble in water. So no aqueous solutions can be prepared for titration. Okay, so which of the following salts can be prepared by acid-alkaline titration? Suggest the acid-alkaline use. If you tell me the acid and alkali use as well. So remember soluble salt first. We just find which one is soluble. This is soluble because sodium ion must be soluble. Ammonium ion is soluble because it must be soluble for ammonium ion. Nitrate is also soluble. Nat2 sulfate, this one is wrong because sulfate will form precipitate with Ba, Pb, and also Ca. Is that right? So therefore this one is solid. This is insoluble. D must not be able. Okay, but C, it is also a problem because when you deal with like magnesium hydroxide, magnesium carbonate, all these things, they are solid as well. So therefore C cannot. The only possible one, okay, will be A and B. So for A, okay, you have sodium ion. So sodium have to be matched with hydroxide. Nitrate, okay, you have to match with acid, HNO3, nitric acid. Ammonia actually is formed from alkaline, which is NH3. The chloride one, then you have to add HCl. So for A and B, okay, which is fissile, okay. So to summarize, okay, this video, okay, we have learned the reaction to prepare salts, okay, that with soluble salts, to be more precise, with Na plus, K plus, and NH4 plus. Okay, the reaction that we can use, okay, I highly recommend you is alkaline plus acid, where something OH, okay, say for example NaOH, KOH, okay, or NH3, okay, don't forget this one, okay. The procedure to prepare and purify to separate the salt, okay. So we'll also specially talk about how to remove the color of the indicator. Remember, the method is to repeat the experiment with exactly the same volume of active alkaline used, and then, but this time, okay, we don't add indicator in it, okay. So that will be the ways that prepare a colorless solution. After that, you just boil the concentrate, cool to crystallize, and then filter, wash, and dry. Okay, the setup of titrations. Okay, remember you have to learn how to draw it. Okay, this one have to be long. Okay, to comparing to the conical flask, because the burette actually the length of it is just like 5 to 6 times, okay, of the height of the conical flask. Okay, so try to draw things, okay, in a correct scale. Okay, so you have the burette, Burette, okay, conical flask, and also white towel. Solution, you have acid, alkaline, and indicator. Okay, so that's all for this video. Remember procedures is the most important part. Okay, bye bye.